This is going to be our classwork help video for the independent, dependent, and mutually exclusive events worksheet. Problem number 1 asks us to determine whether the scenario involves independent or dependent events, and then find the probability. Alright, so you flip a coin, then roll a 6-sided die. What's the probability that the coin lands tails up and the die shows an odd number? So to figure out if these are independent, you just have to ask, can flipping a coin influence the outcome of a die? It cannot, so these must be independent. And when they're independent, you can just multiply their probabilities. So the probability that the coin lands tails up, that's a 1/2 probability. And that the die shows an odd number, that's a 3 out of 6, also 1/2. 1/2 times 1/2 is a 1/4. All right, problem number 2. The bag contains 7 marbles and 7 red marbles and 3 blue marbles. You randomly pick a marble and then pick a second marble without returning the marbles to the bag. What's the probability that both marbles are red? So this is dependent. Whether or not you get a red marble first will affect how many red marbles are in the bag and therefore the next probability. So dependent. All right. You've got 7 and 3, so you got a 7 out of 10 chance that the first one is red. But then 1 red is gone and 1 marble is gone. So you've got a 6 out of 9 for the second. Multiply these together and you get a 42 out of 90. This can be simplified. They're both even, so 21 out of 45. They're both divisible by 3, so 7 out of 15. Yes, that makes sense. All right. Problem number 3. The cooler contains 12 bottles of sports drinks, 7 lemon lime and 5 orange. You randomly grab a bottle, leave it to a friend, then you grab a bottle for yourself. Probably that your friend gets lemon lime and that you get orange. This is still dependent. Even though we're not getting the same flavor each time, it's still affecting the probability when we remove something. So you get 1, and you want to know that if you get orange, so you had a 5 out of 12 chance of getting orange, and then you grab one for your friend and there's 7 lemon limes out of the remaining 11. This gives you a 35 out of 12 times 11 is 132. Okay, let me just take a quick pause. All right, let's see. We'll do problem number 4. So you select a card from a deck of 52, you return it, shuffle, and then select another card. So because you returned it, this is going to be independent. You could theoretically draw the same card twice. What's the probability that the card both times is a diamond? So 13 out of 52 times 13 out of 52. That's the same as 1/4 times 1/4, which is 1/16. All right, determine if the events are independent. So it's giving you the probability of one event, the probability of a second event, and the probability of the union of those two events. Now, if they are independent, so these are just yes/no questions, then probability of A times probability of B should equal the probability of A and B. Well, let's see if that's the case here. 1/4 times 3/4, that is 3/16, which we can see does not equal 3/20. So we'll just say no. Or you can say they are dependent, but they're certainly, you can just say no, and that's fine. Okay, what happens if I multiply these? 7 times 13 over 20 times 20. 7 times 13 is 91. And 20 times 20 is 400, so this one's a yes. All right, I think you can see how easy these ones are. Here, this tells you the two events are independent, so find the missing probability. So that means that this equation has to be true, so P of A times P of B needs to be equal to P of A and B. So now just plug in what we've got. We don't know P of A yet. but we know P of B is 2 out of 5. We know that the union is 4 out of 25. We will multiply both sides by 5 over 2. Times 5 over 2. This will cancel out, make that a 5. This will cancel out a 2. So now we've got 2/5 as our probability for A. Probability of A equals 2/5. All right, same thing here. You end up just dividing that. Here they do it a little bit different. They give you the complement. So probability of not B is 11 out of 12. So we can just immediately figure out that the probability of B equals 9 out of 20. And now multiply the 2 and we get 9 out of 40. Same thing here. Now we got some OR probabilities. Let me just take another quick pause. Got a misbehaving puppy here. All right, so with some probabilities with OR. Oh, and we've got this new symbol. This is a probability of A given B. I don't think I talked about this in the lecture, but probability of A given B. So this means that they are dependent and that the probability of A given that B has occurred first is unknown. So we can use this information to figure out what this is. So the probability of A is 11 out of 20. The probability of B is 1/4. But these do not add up to this. So we got to figure out what the overlap is. So a picture can be kind of helpful here of A and B. This is 11 out of 20. This is 1/4. But when we add them together, we get, let's actually add them together and see what we get. So 1/4 plus 11 out of 20. Let's make a match with that denominator too. So this is 100/400ths plus, let's see, 400 divided by 20 is 20. So 20 times 11 is 220 400. So we got 320/400ths. But added together, we only get 287/400ths. So what's the difference there? So 320 minus 287 equals 33. So 33/400 is the overlap. So that means in here is 33/400. Now the probability of A, so we said this is A, given that you're in B, so the B is 1/4, so that becomes the bottom of the fraction, and the sliver in there is 33/400ths. So the question is, what part of that 1/4 is the 33/100ths? We copied out flop. 33 times 4 is 132/400ths. And I'll just use my calculator to simplify that with the math, enter, shortcut, and I get 33/100ths. Let's see if we did that right. 33/100ths. Yeah, that's a very tricky one. We're going to be working on that more with further problems. Let's just do 14 to make sure we're getting it. So the probability of A and B. So now they're telling you the intersection. So right in there is 7 out of 80. And the probability of B given A, so let's just label this A, this B. So you're already in A, what's the probability that you're also in B? Is 7 out of 20. What's the probability of A? So this 7/80ths divided by the probability of A should equal the probability of B given A, so equals 7 out of 20. We're going to move the probability of A over and then multiply that by the reciprocal, so we get, should be switching up the colors here, 20 times 7 on the top over 80 times 7. The 7's cancel out. 20 over 80 becomes a 1/4. Okay, that was kind of messy. We'll have to do another one of those in the next lecture. All right, last ones. Determine if the scenario involves mutually exclusive events, then find the probability. So a box contains 5 red playing cards numbered 1 to 5, and also 5 black playing cards numbered 1 to 5. You randomly pick a card with the probability that it's red or has an even number. So this is not mutually exclusive. We'll say not ME for not mutually exclusive, because you can get a red and an even number. There are even reds. So of the 10 cards, how many are red or even? So you have the 5 that are red. Those include a couple evens, plus the 2 that are even in black, the 2 of black and the 4 of black. So this gives us a total probability of 7/10. All right, there's 10 shirts in your closet, 4 blue, 6 greens. 3 of the blue shirts and 4 of the green shirts fit well. The other shirts you bag, you randomly select a shirt to wear. What's the probability that it's green or fits well? So are there green shirts that fit well? 4 of the green shirts fit well, so this is not mutually exclusive. What's the probability that it's green or fits well? So let's see, there's 10 shirts in there. 6 of them are green. Now we just have to add in the blue ones that fit well. So 3 blue fit well. So you got a 9 out of 10 chance that you're either going to get a green or a fits well. There's only 1 blue that doesn't fit well and would not satisfy that requirement. Apple or a peach, this is mutually exclusive. You cannot be both an apple and a peach. 5 apples, 4 peaches, so that's 9 over a total of 14. All right, how to determine if events are mutually exclusive? What you gotta do is you try and add them, see if it adds to this. So here, I'll write that out with math first. So the probability of A plus the probability of B should equal the probability of A or B, that's how we write or with that notation, is 1/4 plus 1/2 equal to 3/4. It is, so yes, mutually exclusive. Do these add up to that? That looks like another yes, because that became 18 over 20, which simplifies. This becomes a 4 over 5, which does not equal that. So this one's not mutually exclusive. Okay, I'll let you figure out that last one. All right, we'll call that good for this video. Have a good rest of your day.